So we've got radians versus degrees. We're going to have to be able to go back and forth between radians and degrees. Now, the big idea of radians and degrees is that 180 degrees equals pi radians. And so that's what we're going to keep in mind at all times. Also, some things to keep in mind is that 30 degrees is the same thing as 180 degrees over divided by 6, right? 180 divided by 6 is 30. So if I replace 180 with pi, that means 30 degrees is pi over 6. So we're going to use that to help us. And then likewise, 60 degrees is 180 degrees divided by 3. So that means that it's pi divided by 3. Now you'll notice that 30 is pi divided by 6. And 60 is pi divided by 3. And that's mainly because 6 times 3 is 18. And so when we want to go back and forth, we'll divide by 3 on both sides. So then the 6 goes with the 3. And since we have 180, we're talking about 60 and 30. We've got zeros added on. Okay, so 30 goes with pi over 6. 60 goes with pi over 3. So it goes with the other one. And don't let that confuse you. So what I usually like turning radians into degrees first, because here's what I can do. If I look at pi over 3, if I break this down, I need to change 2 pi over 3 into degrees. So if I first look at pi over 3, it's 180 divided by 3. I'm focusing on the pi being 180. 180 divided by 3 is 60. So now this is really 60 degrees. So 2 times 60 degrees is 120 degrees. Okay, let's try it on the next one. Pi over 6 is 30 degrees, and 5 times 30 is 150. 11 pi over 6, well, pi over 6 is 30 degrees. If I take 11 times 30, I get 330 degrees. Okay, if I jump over here, pi over 2, 180 divided by 2 is 90. So that one you can just do in your head. Now these pi over 4 ones, those are a little bit trickier because it's 135 or it's 45. And it's not as easy to do multiples of 45 because the pi over 4 is going to be 45. So if we look at our unit circle, right? If we look at this, we've got this is pi over 4 and this is 2 pi over 4. And this one right here is 3 pi over 4. And then 4 pi over 4, so it's just pi. 5 pi over 4. 6 pi over 4. 7 pi over 4. Okay, so normally I don't write those because you can count, I just go around the circle and I go 1, 2, 3, 4, 5, 6, 7, 8. Okay, but what we can do is we can write down the degrees. Now this first one is 45 degrees, and then this one is 135 degrees. This one is 225 degrees, and this one is 315 degrees. And so what I do is I notice kind of a pattern. Okay, I've got nothing in the hundreds, and it's 1, 2, 3. So that's the first pattern. And then I start with 45, and then it goes down 35, 25, 15. And so what I'll do if I'm doing a timed thing is I'll quick sketch this out, not as much detail, but what I'll do is I'll say, okay, I've got this, and I put in those, and then I just go 45, 135, it's going down, 225, and then 315. And then when I come over here to this, I say it's 3 pi over 4. So I go 1, 2, 3. Oh, that's 135. So then I write down 135. And then the next one is 7 pi over 4. So I count it 1, 2, 3, 4, 5, 6, 7. That's 315. So if I have it written there, it's pretty easy to find. So that's changing radians to degrees. Now, if we want to change degrees to radians, we've got to be thinking of, is it divisible by 3, divisible by 6, or the 45s, or a 120, a 2 or whatever. But if it's divisible by 6, that's the one that I want to use, because anything divisible by 6 is also divisible by 3, but I want to go with the 6 if it is. So if I look at 210, 6 does not go into 210, so I'm going to go with the 3. And what that means is it's not that I'm going to put a 3 on the bottom. I probably shouldn't have written it that way. That was kind of a bad way to write it. Okay, I'm not going to put a 3 on the bottom because if you remember, divisible by 3 is pi over 6, right? Because that's 30 degrees. Pi over 6 is 30 degrees. So if it's divisible by 3, I'm going to do a pi over 6. And then I say, well, what is 210 divided by 3? That would be a 7. So this one is 7 pi over 6. And remember, for 6, 180 divided by 6 for 6, meaning 60 degrees, I'm always thinking of is it divisible by 30 degrees or divisible by 60 degrees. Maybe I'll put that so it's a little bit better. 60 degrees is pi over 3, right? 180 divided by 3 is 60. So at this next one, 120 divided by 60, that does work. So I'm going to go with pi over 3. And then I say, well, 60 goes into 120 2 times. So this is 2 pi over 3. Let's jump down to the 240. Does 60 go into 240? It does. So I'm going to go with pi over 3. And then 240 divided by 60 is 4, so it's 4 pi over 3. Now let me just show you, if I had done by 3, so pi over 6, 240 divided by 30 is 8. So then I have 8 pi over 6, but that's not good because now I have to waste my time reducing this. 2 goes in there 4 times, 2 goes in there 3 times, and notice I just get back to what that would have been anyway. So try and go, if it's divisible by 60, go with the 60 first. Okay, now we're back to the 135 and the 45. That's back to that picture. And so I got 45 right there. That's the first one, so that's pi over 4. So I'm just going to put that right there. And then I've got 2 pi over 4 and then 3 pi over 4. And now I'm at the 135 spot, which is, which is what I had here. So that would be 3 pi over 4. So again, I'm just taking and I'm counting around the circle. 1, 2, 3. And so wherever I am here, then will be my answer for the degrees. And then 180 degrees, well, hopefully at this point you're saying, well, 180 degrees is what pi is, so I can just write pi there. So those ones should be pretty quick and easy for you. So that's changing between degrees and radians. You have to practice this. And to practice this, I would definitely go and use that unit circle that we constructed where all the angles are on the unit circle, and you have 30 degrees, but you also have pi over 6, and you have them built all the way around. And all you have to do is set yourself up, pick 8 in the radians. So if you have them written on the outside, pick 8 radians. Just go around and pick them, write them down. And then pick 8 degrees, go around and write them down. And then put this away, put the unit circle away, just get out the paper and practice, and then you can check on your unit circle because you have all the answers here and where they match up.